everyone, in this video I'm going to give a little introduction to Lab 2. So to get to Lab 2 you can go to the course schedule and click on the link. You can see that this lab is about functions and selection statements. It's due Friday, May 22nd, no later than 5 p.m. You're going to turn it on Dropbox and make sure your file is named correctly. And it's a hard deadline, so turn in whatever you have at that time. But I would say definitely just get started on this early so that you can ask for help if you need it. So what we're going to do here is we're going to practice writing Python functions and using Python selection statements. Those are those if, else, and elif statements that we've been working on, especially in the selection chapter of the textbook, so you can review that if you need. So the assignment here is to build a program that can take in any amount of income and calculate the U.S. federal income tax for this past year, or I think for this year. 2020. So this could be used, next spring when you're doing your taxes. So you get to start. You start with a partially built program here in taxes.py, and you're going to need to add in the missing function that's going to do most of the work here. And before we actually even go over to that file, I want to make sure that everybody understands how this tax is calculated. And I think the book has stressed this as well, but before you can write your program, you need to make sure that you really understand what the program needs to do. And so here, the way that tax is calculated is a little complicated, so let's just go through that first. So you can see that first off, the federal tax is progressive. So, there's an example here. That's good. If a person has an income of $15,000, the first $9,700 is taxed at 10%, and the remaining $5,300 is taxed at a rate of 12%. So let's actually just go to the Python shell and sort of see what would that computation look like in Python. So we said that their total income was $1,500, right? Or excuse me, 15,000. So just to show what would be incorrect here, right? So even though 15,000 is between 9,700 and 39,475, and so that means they're in this 12% tax bracket, their tax is not. So we would not, we would be wrong if we said tax is just 12% of 1,500. This would be wrong. So we need to do the progressive tax computation. So we're not going to do that. So instead, let's say income in first bracket. So we know that that's 9,700, right? So the first 9,700 is taxed at 10%. So we could say tax from first bracket is what? Well, it's 10% of 9,700. And then how would we figure out how much is in the second bracket? Well, let's take our total income minus income from first bracket, and let's see what that is. Oops. It was income in first bracket. Okay, total income minus. These super long descriptive variable names are biting me in the butt here. Okay. So it's 5,300, just like the example told us. It said the remaining 5,300 is taxed at 12%. And so how would we figure out how much that is? Well, we have 5,300 and we just multiply it by 12%, right? So 636 would be the tax on that portion of the income. And so our total tax would be 636 plus, we saw that there was $970 on that first 9,700, right? So that's the total tax because we have to do it by each chunk, right? So I just wanted to make sure that that was really clear. If you have any questions about that, definitely post on the Slack. But now let's take a look at that file that we're going to need to edit. All right, so we need to download taxes.py. I just save link as, and I'm just going to go ahead and save this as the name that I need to turn it in, right? Oop, lab 2. All right, so that's saved. And now I'm going to open it in idle. Open. And all right, it's right there. Okay, so you can see we have a little header comment here. You're not required to edit this for this lab, but you can. Maybe I will, just for fun. Oops, that was silly. Okay, so I open this up. I see that there's a main function here, and we call it at the end, so that's good. And I see that this main function contains 7 test cases. So what are these test cases? Well, we need to process an income of 5,000, an income of 20,000, etc. And then we're going to be able to compare the output of these test cases to a sample output that's linked on the lab page. Okay, so main calls process 7 times. So what is process? Well, we can see it's defined right here. It takes in an income, so that's good. We're seeing that income argument being passed in every time. It looks like there's a print statement here. And this formatting right here is string formatting. I think there's a note about it on the lab page. Oh, maybe there is not. But for now, I will just tell you that this is printing that income with, I think, only two digits after the period. So, you know, if it was $259.12.543, Python wouldn't know that we only usually want to see the cents. We don't want to see any decimals of cents, so it wouldn't know to not print that, so we have to tell it that we only want it to print out to 2 decimal places. So that's what that's doing. So it's going to first print the 2020 taxable income is, and whatever we gave it. Then it's going to compute the tax owed using this unmarried individual tax function, and then print out whatever that was computed to be. And so you may have noticed that this unmarried individual tax function is not present in the file. I can search for it. Maybe if this was a long file, I would need to search for it, but I can see that it's only found in one place in the file. And another way that I could know that it's not defined is to just run this, and I get that exact error. Unmarried individual tax is not defined. So that is your job in this assignment, is to create that function. So what are we going to do to start? We know that it has to be called unmarried individual tax, and it needs to take in some income variable. You could call this variable whatever you want, but I think it's nice and readable to just call it income. And so what are we going to do in here? Compute the tax owed on the income. So if I was working on this, I would want to make sure that I just develop this in small steps. And so one step might be to just assume, let's pretend that we only get incomes that are less than 9,700, right? Like, it's not true in general, but just to start off, I can just make that assumption and get my program running. So let's say let's say I only need to compute them for incomes up to $9,700. If it's over 9,700, for now, I'm just not going to deal with it. So I'm going to say if income is less than 9,700, then I'm going to compute the tax, right? The tax owed. What is it at 9,700? It's just 9,700 times 0.1, right? And if income is not less than 9,700, so else, my tax owed, let's just say for now is 0, because we're saying we're not dealing with this right now. So I'm just going to save that. And what am I going to need to do? I'm going to need to return whatever I computed as tax owed. So now I have a very first version of this unmarried individual tax function. And what do we expect to happen? Well, we expect to get the right answer for 5,000 because that's less than 9,700. I guess we can even think to ourselves, what should it be? We should get 500, right? Because it should be, oh, this is good. I just saw that I made a mistake, right? You may have caught it when you were watching. So what's my mistake? Well, I don't want to always use 9,700 here. I want to use income, right? Because say 5,000 came in here as my income. It's less than 9,700, so I want to compute the tax owed as whatever that income variable is, which would be 5,000 in this case, times 0.1. So that we would have probably caught that when we ran the program, but catching it now is maybe even better. So when we run on 5,000, we expect to see a tax of 500, but for everything else, we should see a tax of 0, just because that's how we've written our program right now. So let's just go ahead and see if that works. Well, it did not do what I expected. Let's see what happens. Oh, so I said 9,700, but that's actually 97,000, huh? So are any of these above 97,000? Yeah, this is 200,000, 100,000, then it was 0. So if you make a lot of mistakes when you're writing your programs, you don't have to feel bad, because I also make a lot of mistakes. So let's save this now to the correct value, and we'll run it. And now, just like we predicted, the tax is for 5,000, income is 500, and we just report 0 for everything else. All right, so your job then is to keep working on this function, just keep adjusting it until you are computing the right number for every income level. And the last thing I wanted to show is that, oops, this is still up here, huh? Okay, let's get back to, Oh, maybe I've gone away from my lab here. Bear with me while we get to lab 2. Okay, so one really important thing here is that you have a sample output that you need to match. So if the missing function is implemented correctly, this output will appear. So let's go ahead and copy this into, let me show you a tool that I have put on the website. It is a way to check whether two pieces of text are the same. I'm just not finding it. Div checker. Okay, checking your work. So you want to get your program's output and the sample output to be identical. You can use this. There are a variety of tools, but the one that I like best, I think, right now is diff checker. So here I have that sample output, right? So this is what the correct values should be. So in the end, I should get exactly this. And let's see what I have right now. I can just copy these over and paste them in to diff checker. And we already know that these aren't going to be the same, but let's just see what diff checker tells us. And very helpfully, it highlights what is different between the two text bits that you've put in here. And so we can see that, yep, we match for the 5,000 income, but not for anything else. And so maybe you can use this to track down anything that's going wrong in your code. So that is diff checker. Definitely use it because that's how we're going to be grading your assignments. So if you basically run the grade yourself, then you'll know that you'll get full credit. So I think that's everything I wanted to show you for that lab. So good luck. Please ask questions if you have them. Start early. And I think this will be a fun one.